In this lesson, we are going to solve rational equations, and we are going to use the rational equations to solve real-life problems. Our first example is to solve the equation with one solution. So the first thing we want to do, just as we did in the previous lesson, is to find a common denominator. Notice we have an x here, and a 2 here, so we know that our common denominator, our least common denominator, must be 2x. So if we get a 2x in each of our fractions in the denominator, we have to look at what's missing to get our least common denominator. So we have an x here, we need a 2x, so we know we must take the numerator times 2. We have a 2 here and no x, so we know we must take the numerator times x. And we have an x here and no 2, so again we're going to take the numerator times 2. So this is going to give us 6 over 2x minus x over 2x equals 24 over 2x. Notice now we have the same denominator in all of our fractions, so what we're allowed to do is simply work with the numerator from there on. So we have 6 minus x is equal to 24. Solving for x, we get negative x equals 18. Divide by negative 1, you get x is equal to negative 18. And that is your solution. In the next example, notice we have an x plus 1 here, so we're going to be needing to check for extraneous solutions. So first things first, as usual, we have to find our least common denominator, which we know that 4 is actually 4 over 1, so our least common denominator is going to be x plus 1. So we need to look and see what we can do to get everything having the same denominator. We don't have to change anything with our first fraction, but we need an x plus 1 under our 4, so we know to do that we must take both the numerator and the denominator times the same thing, so we're not changing its value at all. And again, in the last fraction, we don't have to change anything because it's already at an x plus 1 in the denominator. So once again, we have the same denominator in each of our components of our equation, so we can just work with the numerator again. Pulling that down, we get 5x equals 4 times x plus 1 minus 5. We need to distribute this 4. So we have 5x equals 4x plus 4 minus 5. Simplifying and combining like terms, we get x equals negative 1. Now we have to check this solution in our original equation to check for extraneous solutions. Notice that if we plug a negative 1 in, we're going to get negative 1 plus 1, which equals 0. And we know that we cannot have zeros in our denominators. So in this particular equation, we get no solutions because our only solution was extraneous. In our next example, we are going to be solving an equation with two solutions. Notice we have an x squared in our denominator here, so that's sort of the hint that we're going to be getting two solutions. So first things first, as usual, we find our least common denominator, and what we want to do first is factor out this expression so that we know what we're working with. In our first fraction, we have 3x minus 2 over x minus 2. In our second fraction, factoring that out, we're going to have x plus 2 and x minus 2, and then we're just adding 1, which we know is over 1. So looking at our three fractions here, it looks like our least common denominator is going to be an x minus 2, which we know that we have common in both of these, and also an x plus 2, because it's here. Well, and also a 1, but that doesn't really affect anything. So our least common denominator is going to be x minus 2 and x plus 2. So now we have to make sure that all of our fractions have the same least common denominator. So x minus 2 and x plus 2 from our first fraction. What are we missing from our least common denominator? We'll notice that we're missing an x plus 2 there, so we have to take the numerator times the x plus 2 so that we're not changing its value at all. Set that equal to, we know that our second fraction already has both of our terms in its denominator, so we don't need to change the numerator at all. And in our last fraction, which is just 1, we need both of our new terms in the denominator, so we have to multiply the numerator by both of our new terms as well. Again, we have the same denominator in each of our fractions here, so we're allowed to just work with the numerator. And what I'm going to do is multiply these out so that we get it in simplest form. So we're going to have 3x squared plus 6x minus 2x minus 4 is equal to 6 plus, multiplying these together, we're going to get x squared minus 4. Once again, we're going to combine like terms, so that will leave us with 2x squared plus 4x minus 6 is equal to 0. Notice we have a greatest common factor of 2 here, so we can divide that out of each term, which is going to leave us with x squared plus 2x minus 6 equals 0. Factoring this out, because we need to find our solutions, we're going to get, this is minus 3, because remember we had to take a 2 out of everything. Sorry about that. So now we can factor this nicely, and we'll get an x plus 3 times x minus 1 is equal to 0. Solving for our x values, for our solutions, we're going to get x equals negative 3 and a positive 1. Once again, we have to check for extraneous solutions. So if we plugged a negative 3 into either of these, we would be fine. We would not get 0 in the denominator. And same for 1. We'd get negative 1 here and negative 3 here, so we're fine. These are our two solutions to this equation. The next term we're going to cover is called cross multiplying, and we use this when each side is a single rational expression. So if we have a fraction equal to a fraction, we can actually just cross multiply these, so we get rid of our fractions and we just get AD equals CB. If that's hard for you to understand, you can stay on this slide while I explain it. If not, you can go ahead and move to the next slide. So we know that if we want these equal to each other and we want to solve them, we need a common denominator. So our common denominator would be BD. What are we missing from the first term? We are missing the D, so that's going to give us the AD. And what are we missing from the second? Well, that will be our B. So we have CB on this side, or BC, whichever. And like our previous examples, now we have the same denominator, so we can just work with the numerator. So we're left with AD equals CB. That's just a mini little proof there of why the cross multiplication works. So now we're going to do an example where we're going to be applying the cross multiplication. Notice that we have a single rational expression on each side of the equation, so we can use our cross multiplication method. It helps me sometimes to actually draw this out so I know what I'm multiplying together. So if we do our first two terms, we're going to get 3 times x plus 4 is equal to 1 times x squared plus 4x. We know that 1 times anything is just the self, so we don't really have to worry about that. Distributing the 3, we're going to get 3x plus 12 is equal to x squared plus 4x. We know we want to solve for x, so we have to get all these on the same side. So we're going to get 0 equals x squared plus x minus 12 equals 0. Oops, I already have the 0 on the other side. Now we need to factor this, so we get 0 equals x plus 4 and x minus 3. Solving for our x values, we get x equals negative 4 and positive 3. Once again, checking for our extraneous solutions, we plug negative 4 into, this one's not going to work out, right? Because if we plug negative 4 in, we're going to get a 0 here. So we know that negative 4 is extraneous, because we can't have 0 in the denominator. And if we plug 3 in, we're going to be okay. So our only solution to this equation is x equals 3. In our last example, what we're going to do is apply our new methods to a real-life problem. So it says a construction crew can pour a slab of concrete in 8 hours. When another crew helps, they finish the same job in 3 hours. How long will it take the second crew to do the job by themselves? So there's two ways that we can do this. We can write a simple equation first, or we can plug these values into a table to help us see it better. So I will do it one way first and another way second, and we'll notice that we're going to get the same answer. So the crew number 1 gets one job done in 8 hours. So we have 1 over 8. Our second crew gets one job done in X hours because we don't know how long it will take them. And if they do it together, they get one job done in 3 hours. But if that's not very easy for you to see, we can put it into a table. So we have our first crew and our second crew. We have their work rate. We have the time it takes them to finish. And we have the actual work. So our first crew gets one job done in 8 hours. Our second crew gets one job done in X hours. The time that they have is 3 hours. So if we multiply across, we get total work of 3/8 and total work of 3 over x. So what we do then is we combine the two work to get one job. 3 over 8 plus 3 over x equals 1. Now in both equations, notice one job, if I'll back up for a second, equals 1 because they're doing one job, and these are their rates. Okay, so notice that we have very similar fractions in each problem. Now, we want to find a common denominator, so we have 8, 3, and x. Notice there's nothing common in any of those, so our common denominator is going to be 24x. What are we missing in the first fraction? 3x. What are we missing in the second fraction? 24. And what are we missing in the last fraction? 8x. Now if you'll notice, I sort of jumped ahead and I applied the same idea to our other side here. If you're doing it this way, finding the least common denominator, we get 8x. So we'll be left with 3x plus 24 equals 8x on this side. Now these, if you'll notice, are the very same problems. We just got there in two different ways. Whichever way you choose doesn't matter to me as long as you're coming up with the right equation. So in both situations, we have the same denominator in each of our fractions. So we can just work with the numerators. And once again, these are going to be the very same in both situations, so you can follow along whichever way you choose. 3x plus 24 equals 8x, the very same. So we solve for our x. 24 equals 5x. X equals 24 over 5. Now let's remember what we're searching for. It says how long would it take the second crew to do the job themselves? Well, 24 over 5, we should probably approximate a little bit better. So we're going to get 4.8, and what are we looking for? Hours. So the same job that takes crew 1 8 hours will take the second crew about 4.8 hours. As a quick review, we just want to go over some helpful hints to remember when we're solving our rational equations. And the first is find the least common denominator. Before you make any moves, make sure that all of your fractions have a similar denominator. Second, make sure you're checking for extraneous solutions. Even when you think you might not have to, you do. So make sure you're checking for those extraneous solutions. And last, we learned that we can now cross-multiply when each side of the equation is a single rational expression. And that will conclude the lesson.